This video I want to introduce a Python script I created for visualizing portfolio theory in financial markets and stock markets. And you could say this is an application of Markowitz portfolio theory in Python, and more specifically a visualization of Markowitz portfolio theory in Python. What I will be doing is I will take 8 stocks and I will combine them into portfolios. A portfolio is nothing but a combination of stocks, and well, in your portfolio you can choose how much you weigh the different stocks. So you can, for example, choose to invest everything into one stock, then you would be applying a weight of 100% to that stock and 0% to all the other stocks. Or you could, for example, choose to invest the same amount of money into all stocks, then you would have an even distribution of weights, or all the weights would have the same value. Or you could have some other combination of weights and basically create a different type of portfolio. And what this plot shows you are 500,000 randomly created portfolios for 8 specific stocks. And you can see here that there's an efficient frontier somewhere around here. So when looking at the historical stock data for those stocks, then for example, for a standard deviation of 0.03, the best portfolio to choose in order for you to maximize your returns was located somewhere around here. And from that you could backwards then derive the, historically speaking, optimal combination of stocks, or the optimal weight that you should apply to the various stocks if you want to maximize your return at this level of standard deviation. Whereas a portfolio down here, for example, would be inefficient and it would not be rewarded or reimbursed by the market, since this would, for example, be a portfolio that has the same level of risk, so the same standard deviation, but would not have the maximum return, historically speaking. So there were a lot of other portfolios that had the same level of risk but were able to create a higher return. So the market would demand, historically speaking, this level of return for this amount of risk, for this combination of stocks. So this is what you could use this model for, and what it is used for. One of the major shortcomings of this model is, of course, that it's based purely on historical data, assuming that what you derive from the historical data is applicable or can be used for creating an optimal portfolio for the future. And this is, of course, simplified. Nevertheless, it is a very popular model also in financial markets related trainings and classes. So also at university, this is a model that is often taught. But to start with, these are the stocks that I will create my portfolio from. The reason for that is I wanted to create a trucking and freight related portfolio. I usually make videos and blog posts on supply chain, data science, or production logistics. So this is why I chose transport related stocks. And let's say we want to create a fund that is focusing on freight industry, then those would be some of the biggest freight related stocks I could choose from. And now the question is, what's the optimal combination of those stocks? So how much weight should I apply to the various stocks in order for me to be able to offer my clients the best possible portfolio? And for this I will now derive the historical stock price data for those stocks. For this I will use Pandas Data Reader, which will return stock price data in a Pandas data frame. So this is why I'm also importing Pandas. I will be calculating statistics. I will be creating random weights, since I'm creating random portfolios. So this is why I'm also importing random. And I will be doing visualization with Matplotlib. So this is why you also find Matplotlib here. I'll also be doing some some array wrangling and some calculations with NumPy arrays, so this is also why I'm importing NumPy. And my dates to define the start and end date for my period for which I will collect the stock price data is defined here by datetime objects. So you can see here I selected the data for a period of 6 months between the 1st of April to the 30th of September in 2020. Here I'm creating a helper function that will take in a data frame returned by Pandas data reader. It will derive the closing prices and it will calculate the daily returns for this stock that is represented by the data frame handed over to the function. So this function takes in a Pandas data frame for a given stock derived from Pandas data reader and returns a list of daily returns for this stock. Here's another helper function that takes in a list of stock tickers. So the stock tickers are the abbreviations that are indicated here. And it will take in a start and end date. It will then loop through all the stock tickers. For each stock ticker, it will retrieve the stock price related data from Yahoo Finance for the defined period. It will calculate the average daily returns and the standard deviations of daily returns for the stock. And it will append this to an return and standard deviation list. And then it will keep looping through the stock ticker, so it will take the next stock, retrieve the data for it, calculate the mean return and the standard deviation of return for that stock, append it to the list, and so forth. So in the end effect, it will return a data frame that contains information on the stock and the thereto related average daily return and standard deviation of daily return. This is in the end effect then what is done here. So here I apply the function on the stock tickers indicated up here, and here you can see the stocks indicated by the tickers. You can see the average daily return and the standard deviation of daily return. This is also visualized here in this plot. Here you can see how the various stocks performed historically speaking for the period I mentioned. Here you see the standard deviation of daily return. Here you see the average daily return. So further down here I define another function that is another helper function. It's called portfolio builder. It takes in a parameter value n, which is an integer that specifies how many portfolios I want to build. Here are the stock tickers for the, you could say, base stocks. Those are the stocks I'll be creating my portfolio from. And here's the start and end date for the period I want to collect data for. The function will loop through all the stock tickers. It will retrieve the stock price related data from Yahoo Finance using Pandas data reader. It will calculate the daily returns. It will remember those daily returns by appending those values to an array. And then it will loop through the number of portfolios it's supposed to create. So when starting this loop, it has now the historical information, so the historical average return and the standard deviation of daily return for the base set of stocks. And now it will loop through the number of portfolios it has to create. It will create random weights, and then it will be combining the stocks into a portfolio based on those randomly selected weights, and it will calculate then the average return for that portfolio and the standard deviation of that portfolio, and it will remember those values by appending the respective value to an array, which is then in the end returned. So what I receive here in the end is a list, a two-dimensional list that contains a sublist with the standard deviation of daily returns for the various portfolios and a sublist with the average return for the various portfolios. And this is what I apply down here. So here I use this function portfolio builder. I set n to be 500,000, so I'm creating 500,000 random portfolios, and those are then the ones I'm visualizing here. And as I said, what this model or this plot shows you is, when looking at historical data for this set of stocks, the efficient frontier, which I should be aiming at, or that I should expect the market to assume, is somewhere around here. So if I want to create a portfolio that has a risk of, let's say, 0.02 standard deviation in returns, then the market will expect, based on historical data, an average daily return of somewhere around here. And this is basically what I could be using this model for. If you want to use this coding example as a template, then you can click the link in the video description and you can find all of this coding on my blog. And then you can try to use it as a template and make your own model and make your own application of it. Maybe you can create your own fund or your own stock portfolio for yourself by using this template.